if errors are there, so we can think about some error recovery policy. So, the problem with the lexical error is that the input string, input file that we have or input stream. So, there is some problem in the input stream itself. So, if you are thinking about correction, so you have to correct the input stream, and if there is no look back, okay. So, a lexical analysis tool, so it is scanning the input file from one side and going towards the other side. So, it has already scanned some portion which needs to be corrected. So, the lexical analysis tool has to undo some operations that it has already done for correcting the text or doing some recovery. So, one possible recovery mode is the panic mode of recovery. So, panic mode of recovery here it is said that the successive characters are ignored until we reach to a well formed token. So, some tokens are very unique. For example, semicolon is a unique token. Then say if you are considering say C programming language, then these symbols like open brace and closing brace, so they are unique. Similarly, if we get a closing parenthesis, okay, so that may be meaning end of an expression. So, like that certain tokens are certain character sequences are unique. So, if you find that there is some error, so when it was going through this part, so it can go on ignoring all these characters till it gets a closing brace, because after the closing brace it is I can assume that from this point a new correct token will start. So, in a panic mode of recovery, so it will ignore all these tokens and it will start it will be starting afresh with the next synchronizing token. So, or synchronizing symbol. So, this is good because I can the lexical analysis tool, so it can come out of the error and continue processing of the remaining one. So, another possibility is that delete one character from the remaining input. So, this is just one possibility that you delete one character with the expectation that from the next character I will get a valid one. So, as I was telling that the example that I took previously, like say 2R. So, after getting 2, so I was expecting so to return this as a number, I expect that at this place I should have a blank or some operator, say plus or multiplication, some operator. So, what I do, I just ignore the next character. So, maybe after R, after this R there is a blank. So, if I delete this R, then I will get this 2 as a valid token. So, this way I can delete one character from the remaining input and accordingly I can make a valid word out of the whatever I have scanned, or I can insert some missing character into the remaining input. So, here also the same example, like if it is 2B, then I can insert one blank in between. In that case, this 2 will be returned as some number, and after that B will be returned as an identifier. So, that will solve the problem for the lexical analysis tool. Now, whether this is correct or not, that is not the concern, because it may or may not be correct, but the lexical analysis tool, it got stuck at this point. So, it was unable to proceed further. So, if we do this, then it will be able to proceed with the remaining input, and maybe it will do something, maybe it will flash some error message and the user will correct it, but it can give a large number of errors reported to the user. Otherwise, it will stop at that point and it will come out from this compilation phase telling that there is there is an invalid character at this point. So, it will alter only this much. So, that is not there. Sometimes we replace a character by another character. So, that is also another recovery policy. So, if you so there may be alternative words that are available. So, maybe one in some word, so only one character is wrong. So, what it does is that it modifies that word completely with a valid word. So, normally for this purpose we have got this text processing softwares which do this thing. So, they have got some dictionary of words, and it whenever it finds that some word is coming which is not matching. So, it will try to replace it by some valid word. So, it will try to replace a character by another character, or it can transpose two adjacent characters. So, two characters, suppose I have got this f I. So, if I do a transpose, so these two characters will change the interchange their positions and it will give me I f. Okay. Similarly, so for while I am trying to write the keyword then, maybe I have actually written T H N, and then if I transpose these two characters, then it will become T H E N. So, this type of corrections can be done by the error recovery phase. So, whether so how many of them will be done and whether it is done always, so it is up to the compiler designer. So, language design will not talk anything about error recovery. So, it has got nothing to do with the code generation also, because if there is a mistake in my program, so that is a mistake, that is an error. So, it will not generate the code, but the compiler designer can think about this type of possible errors and flash a good number of error messages, good amount of error messages, so that the program can be corrected by the user. So, it is up to the user to, it is up to the compiler designer to identify possible or visualize possible mistakes that the user may do, and accordingly come up with some policy for the recovery. Sometimes we need to do some buffering, some lexic analyzer it needs to look ahead some symbols to decide about the token to return. So, typical example may be these symbols, like in a C programming language we have got these symbols, a minus, then equality, less than. So, we have to look ahead and then only we can see, we can do something, can return the proper token. For example, if you have got say x minus y. So, at this point if the input if your input pointer is somewhere here, so you have got a this minus symbol. So, should I return the token minus? Okay. So, it is not, it may or may not be correct, because it may be the user has written x minus minus plus y, user has actually written this and you are at this point now. Now, getting this single minus, it should not return a minus. The lexic analysis tool, it should look ahead, see the next minus and then this blank, and then it should say that this minus minus. So, this is basically a auto decrement mode. Okay. Similarly, this equality, looking into one equality, so whether it is correct or not, that is a question, because I may have two equalities. So, x equal to y and x equal to y. So, both are valid in the C programming language, and if the user has written like this, then if we are returning that it is an equality operator, so that is wrong. So, you have to say that it is an equal check operator by saying by seeing both these equality symbols, you should return a single token which is the equality check. So, this way this lexic analysis tool it needs to look ahead. Similarly, this less than we have got many variants, like less than is there, less than equal to is there, then we have got this left shift. Okay. So, all these are there in the programming language. So, depending upon the programming language, you may need to look ahead for the next few characters to know what is the valid token, and in general the policy followed by the lexicon analyzer is that it returns the maximally matched token. Okay. So, it will return the maximally matched token. So, whichever token matches with the next maximum number of characters, so that token will be returned. A very nice example that we have is the Fortran language. So, Fortran language it has got a loop construct. So, where the structure is like this, the do loop. So, do then a label, and then we have got some variable I equal to say 1 comma 25, and then you write the body of the loop, and then somewhere at this point. So, you have this label, and here you say continue. So, means that this body of the loop will be repeated first with I equal to 1, then I equal to 2, etcetera, up to I equal to 25. So, this is a valid this is some example that we are doing. So, actually the user wanted to write in this case do 5 I equal to 1 comma 25, but by mistake this 1 comma 25 has been written as 1 dot 25. So, this 1 dot 25, so this is a real number which is allowed in Fortran language, and Fortran language it does not recognize these blanks in between the symbols. So, it just ignores this blank. So, this entire do 5 blank 5 bi, so this whole thing is reduced to a variable do 5 I. So, it thinks that this do 5 I is a single variable that is equal to 1.25. So, this is the interpretation of this particular statement. So, until and unless you have seen whether this is a comma or a full stop or dot. So, you cannot know whether you should return do as a loop token or this do 5 I as a identifier, as an identifier. So, you see the level of complexity that this lexical analysis tool is going to face. So, it has to look ahead quite a few characters to see whether a comma appears after the first number after the equality symbol. If it is not, then it is the whole the entire left hand side will be reduced to a variable name, whereas if it is a comma, in that case it has to return only the do part and the input pointer should be pointing to the next character here. Whereas, in this case if it is 1.25, then the input pointer will come to this point. So, this type of things are there. So, designing lexical analysis part is not that simple. Okay. Apparently, it seems it is quite simple. I will just do a simple string match and wherever I get the match I will return it. So, that is not the case, because programming languages are often very cryptic in nature. Okay. So, and that is up to the language designer, they have done it like that. So, we have to follow that. So, sometimes we need to introduce a 2 buffer scheme to handle large look ahead safely. So, that when one buffer pointer is advancing through one buffer, the other buffer holds the next symbol set, next input string. So, that way there is no possibility of overflow. Sometimes we need to save some amount of buffer information onto some onto the other buffer, so that these symbols are not lost in the process. Anyway, so they are all implemented in the Lex tool. So, while designing the compiler, we do not really feel that we have to do so complex things, but the Lex tool that is there, so it takes care of that. Next, we will come to a very important part of this lexical analysis phase, which is known as specification of tokens. Like, how do you tell what are the valid tokens in your programming language? So, any language or not only programming language, any language. So, as I said, any language has got an alphabet which defines the characters or symbols that the language can have. So, if we are talking about say the set of sentences over binary symbols, then my alphabet set is often represented as sigma. So, this has got 0 and 1 in it, only 2 symbols. Then if I say that we have got say the English language text, then all these symbols A, B up to Z, then this capital A, B up to Z, then we have got these numbers 0, 1 up to 9, then all the symbols that I have in the English language. So, they will come as a alphabet set for the language. So, from this alphabet set, we have to define some rules by which I will tell what are the valid strings or valid words for the language. So, here we will be using a particular structure known as regular expression to formalize the specification of tokens. Okay. So, we will be learning about regular expression for that purpose. So, regular expressions are means for specifying regular languages. So, I will come to this regular language part slightly later when we go to the parser phase, parsing phase, and we talk about the grammars and all. For the time being, we take it as accepted that the regular expressions can specify regular languages. So, what is a regular language? We will learn it later. So, a typical example of a regular expression is like this: letter, then within bracket letter, then vertical bar, digit, bracket close, star. So, where this letter is a set of symbols. So, any letter, maybe I can say the letter set is the set letter is all the lowercase letter that we have in the English language. Then digit, so this is a set of symbols 0, 1, 2 up to say 9. So, these are digits. So, it says that this whole thing is a regular expression which must start with a letter, and after the letter I can have a letter or a digit, and this letter or digit can occur any number of times. So, this star at the end means that with whatever portion on which you have applied this star, that can appear any number of times. So, if I write like A B, so that is a valid word for this particular regular expression. Then I can have say A 2 B or A 2 2, okay, or A 3. So, A all A's, anything that we can write like this, but anything that does not start with a letter is not valid. Like if I ask whether this 2A is a valid word as per this rule or not, so it will say no. So, this is not correct, but all these are correct, all these are correct, but this is not so. So, we have got this particular rule where this, so this is a regular expression, this whole thing is called a regular expression. So, some time back I was telling how are you going to specify the patterns that are allowed for the programming language. So, this is actually the this is done by means of the regular expression. So, you have to define the set of regular expressions for your language that will define all words that you have in your language. So, each regular expression is a pattern that specifies the form of strings for the language. So, the type of strings which will correspond to this regular expression, so that will be identified by this regular expression. So, every token, now you can understand that each token has got a corresponding regular expression. So, for example, previously I talked about the token if. Okay. So, the corresponding regular expression is simply if. This is the corresponding regular expression. Similarly, if I have got say comparison operator. So, the comparison, this particular token. So, the corresponding regular expression is equality or greater than or less than or greater equal or less equal. So, this way you can specify the token. So, the corresponding regular expression. So, each token will have got a corresponding regular expression, and the task of the lexical analysis tool is to see which of these regular expressions maximally match the next part of the input. So, if this is your entire if this is the entire input file that you have, maybe at present the lexical analysis tool is at this particular line and in this particular character. Now, if you ask, when the parser asks it for the next word or next token, what it does? It scans from here and sees which token matches maximally. Okay. So, it finds a maximal match, so maybe the maximal match is up to this much, this entire thing maximally matches with some token. Then this entire thing will be, so that is checked by the regular expression. So, this entire part matches, the corresponding token will be returned. So, it is the task of the lexical analysis tool to see which token matches or which regular expression matches maximally from the given set of regular expressions and return the corresponding token to the parser. So, this is how this lexical analysis tool is going to work. So, we start with the definition of regular expression. So, epsilon, okay, so it is a regular expression denoting the language L of epsilon equal to epsilon containing only the empty string. So, throughout our discussion, so this epsilon will be, so this will be calling as, this is a special symbol. So, we will be call this as null. Okay. So, wherever you find this epsilon, so you take it as null, there is no is a void sort of thing you can say. So, this is a special regular expression. So, if your language, so if your language contains only the null string, Okay, that is a very rudimentary language that has got only one string, which is a null string. So, that is or the empty string. So, that is represented by the regular expression epsilon. Then if you have got the symbol a, small a in the alphabet set sigma, then a itself is a regular expression corresponding to the language that has got the string which contains only a single a. So, in my sigma, in the alphabet set, I may have all these symbols, say A, B and C, fine. Then L of A means it is talking about the language that has got the alphabet A only, it does not have the other two alphabets B and C. So, naturally, so L of A is only the, it has got only a value, only a single valid string in the language, which is a single A. Okay. Similarly, L of B. So, each symbol that you have in the alphabet set constitutes a language consisting of a single occurrence of that symbol. Okay. So, L of B is a single B, L of C is a single C. So, it defines those languages that contains a single B or single C in it. Now comes combination of two or more regular expressions. So, if R and S are two regular expressions with corresponding languages L of R and L of S, then R vertical bar S is a regular expression denoting the language LR union LS. So, when I say LR, so this is LR is nothing but set of strings in the language with R as regular expression. So, that is LR. So, this is a set, it defines all the strings that are possible in the language identified by the regular expression R. So, when I say R vertical bar S, or we read it as R or S. So, if LR and LS are two languages, then this R vertical bar S, it will correspond to the language LR union LS. So, L of R or S is nothing but L of R union L of S. So, any string which belongs to the language LR also belongs to the language LR or S. Similarly, any string which belongs to the language LS also belongs to the language LR or S. Next, we look into the next rule. It says that if RS is a regular expression. So, R is a regular expression and S is a regular expression, and they are occurring side by side. So, for example, A is a regular expression and B is a regular expression, or I can say say AB is a regular expression and BC is another regular expression. So, that way maybe my R equal to AB and S equal to BC. In that case, RS is this one ABBC. So, if RS is a regular expression, then that will denote the language LR followed by LS. So, any language, any string that is created by taking one string from L of R and another string from L of S and concatenating the second string to the first string. So, you have got say one language L of R, suppose it has got the language, it has got the strings A, AB and AC, and L of S has got the strings X and Y. Then L of R S, so this will have all these strings like AX, AY, ABX, ABY, ACX and ACY. That is, you take the first part from the language LR and second part from the language LS and concatenate the two strings together. So, what you get is the set of strings that are allowed in this language. So, if you have constructed individual languages for the regular expression R and S, so you can take concatenation of those strings of different languages and tell them that it is the regular expression for it is the language for the regular expression R s. So, this is there. Then we have this special regular expression R star. So, R star means this star symbol, it means that it is 0 or more occurrences of the regular expression R. So, if you have got say L of R, suppose I have got the two strings A and AB, then L of R star, so this will have all these words, all these strings. So, 0 or more occurrences of this language words. So, if I take 0 occurrence, so that is the null, so epsilon. If I take 1 occurrence, so I can get A and AB. If I take 2 occurrences, then I can get AA or AAB. Similarly, ABAB, ABA. So, this way you can think about different words, okay, different strings, okay, and this set is infinite because this is 0 or more occurrence. So, you can just go on augmenting, taking more and more strings and connecting them together a different number of times. So, it is I have taken only 2 times. So, you can take it any number of times because this is a star. So, this R star is a regular expression denoting L R whole star, the set containing 0 or more occurrences of the strings of L R. Okay. So, and each whenever you are taking the string, so you are free to choose any string. So, that way they can be concatenated in arbitrary fashion. So, this is the this is a very powerful operator that we have, okay, unlike this or say consecutive occurrence. So, this star is a 0 or more occurrences of the symbol. Then within bracket R is a regular expression which corresponding to the language L of R. So, it is nothing new. So, this R, the regular expression R has got the language L of R. So, if you put it within bracket also, we do not get anything new, we get the same language L R. So, this way the regular expressions are defined. So, this is a definition of regular expression. So, here is some example. Suppose, so we have got this thing like regular definition. So, definition 1 will give me some regular expression d 1, definition 2 will give me some regular expression d 2, definition n will give me regular expression r n. So, one such definition is say letter underscore. So, that means I am talking about, so this is a definition which says that all these characters can appear A, B, capital A, capital B up to capital Z, then small a, small b up to small z and this underscore. Then this digit is a definition which is 0, 1 up to 9 and ID is another definition. So, these are specified in terms of regular expression only. So, you see this whole thing is a regular expression. Similarly, this whole thing is a regular expression. Now, I am using these two definitions to define an ID. How am I defining? Letter underscore followed by letter underscore or digit and this is star. So, I can start that means for a valid ID, for any character string to be called a valid ID. So, it may start with a letter or it may start with the underscore character. So, maybe so I can have a character string like this underscore AB. So, that is valid. Similarly, I can have like A underscore B 2 underscore 3. So, this is also valid. So, they are all ID, they will all be identified as ID. So, this can be done. So, we can have this type of regular expressions formulated by first writing a few definitions and then writing the more complex one, building the more complex one based on the simpler regular expressions. So, these are called regular definitions. So, we can use these definitions to build more and more complex things. And so, you can understand that anything. So, this is not valid, like you cannot say like 2 underscore 5. So, that is not a valid one, or 2 underscore a, that is not valid one, because it says that it should start with a letter or underscore character, but here for these two cases that is not true. So, they are not valid, whereas these cases they are fine. and they can occur any number of times. So, in the first character, so even this is going to be a valid string. So, all underscore, and this can go up to infinite. So, this is also valid because I am starting with an underscore that satisfies the first part of the definition, and then I am starting with then I am doing with say this second underscore, and that is satisfying any number of times. So, this is also a valid ID in the as per in this particular language.